So first of all, guys, I just want to let you know that I'm risking my life by coming to the school here where it's empty in the midst of spooky season. So please just watch this and appreciate it. Up at the tippy top, this time I remembered to write name before I made 170 copies, so I'm going to write my name. Obviously, you're not going to write Miss M because you are not me. You're going to write your name there. We have a graph here that we're going to work through. I'm going to get you guys started. It tells us right here that we're going to be creating a bar graph. That's just like the one that we created on our green packets yesterday. So, I'm going to get you guys started with the bar graph. The back of the paper is a line graph, which we haven't talked too much about, but I do want you to go ahead and get started if you finish this front side. So, planets and weight. Macy loves learning about space and wants to know if her weight is different on different planets. She finds a planet weight calculator on a website and records the results in a chart. Then we see over here we've got our chart. It says planet in the top of the left column and weight in pounds in the right column. So when we are looking at a data table, it makes it even easier to find our IV and DV because our independent and dependent variable are going to be the titles of each column of the graph. So we always put our IV first and our DV second. So what that tells me right away is that my independent variable is going to be the planet and my dependent variable is going to be the weight. When we are making graphs, we are always going to use the title, the effect of, so we've got the effect of IV on DV. So our IV here we said is planet. So I'm going to go ahead and I'm going to circle planet and underline weight, just like we've done with all of our others. So the effect of planet on weight. Now, of course, you guys do not have to make yours all colorful like this. I just wanted to change the color so you could see exactly where we have the parts of our formula and then where we've got our IV and our DV that we just plug in there. So the effect of planet on weight. We talked yesterday about how our thumb over here is independent when we make our hand like an L. So my thumb is independent. I'm going to put my independent variable down here on the x-axis because it's at the bottom. So my independent variable here is planet. So I'm going to label down here. On this line here, I'm just going to write planet. My other four fingers are dependent on each other. So over here on the y-axis, we are going to write our dependent variable, which is weight in pounds. So I'm going to write weight, and I'm going to go ahead and make sure that I keep that label. LBS, for some reason, is the abbreviation for pounds. Don't ask me. I couldn't begin to tell you why. So we had our first step, which was to identify our independent and dependent variables. Our second step was to write our title, and then our third step was to write the labels here. So if you are ever stuck on how to go through the process of creating your graph, we have this lovely green packet that you're going to hold on to clear through May, right? So we have our graphing steps out here. Obviously mine's blank, but we've walked through the first three steps here. Our next step is intervals. So we talked a lot about intervals yesterday. And when we are making our intervals, the first thing we want to do is look for the largest number. So I'm looking down through all of my planets, and I can see here Jupiter, my weight would be 252 pounds. Thank goodness we've got big numbers here, right? Because we're going to do lots of division. So, when we divide to find our interval, we are going to count up all the boxes. We found our largest number. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Lovely numbers. This 25 divided by 13, 250 divided by 13 feels a little familiar, doesn't it? So I have my 252.8 divided by 13. And what I can do is, if I don't remember doing that in class yesterday, then I would pull out my handy dandy calculator that I clearly have set up right near me and I'm not looking for right now as I'm in the middle of making a video. So I've got my calculator, which I don't have a calculator because I'm not a student, but I've got a phone. You guys are obviously going to have your phones in your lockers. So I have 252.8 divided by 13. Because I've got 13 boxes, that's going to give me 19.4. Just like yesterday in class, we're going to round up so we are not doing weird intervals with decimals. So my 19.4 is going to round up to 20. So I'm doing intervals of 20. So I am starting down here with 0 always. I'm going to count up by 20s. And remember, when I say 20 over here, what that means is 20 pounds. So every bar represents 20 pounds. So if I look at my lowest number over here, looks like Mars is going to be my lowest at 37.7. So 37.7, I'm thinking that's going to be less than 40 pounds right there. So just to kind of give you an idea of what size bars we're looking at. So I'm counting by 20s. It's exactly like counting by 2s, but we're going to throw an extra 0 on the end. We need to make sure we get all the way past that 252.3 for Jupiter, which it is looking like we should. Like I said, very familiar compared to yesterday. We're ending on 260. Yesterday we ended on 26. Fabulous. Now, of course, before I can start making any of my bars, I have to figure out how wide, where each of my bars are going to go. So we are going to start. Yesterday we did bars that were 2 blocks wide. We've got to fit 8 planets on here, so it's looking like we probably can't do 2 bars wide, but I'm going to check real quick if we can fit just 1 bar. So I'm going to skip the first one. I'm going to do this with a pen just so you guys can see it a little bit better. So I'm going to skip the first one, 1 block wide, skip, 1 block wide, skip, 1 block wide, skip, 1 block wide. We were at 1, 2, 3, 4, 5. I'm making sure that I skip 1 block in between all of these. So I have 1, 2, 3, 4, 5, 6, 7, 8. I have 8 planets listed up here. Sorry, Pluto. And now we're going to go ahead and we're going to label each of our planets. We're going to go in the same order that it gives us over here in our data table, which fortunately is the same order that our planets are from closest to the sun to the farthest from the sun. If you don't know those yet, you sure will in a few months. So we're going to start here with Mercury. Next we're going to go Venus. My most familiar planet, Earth. Mars, Jupiter, my personal for literally no reason, Saturn, personal favorite, I forgot that word, Uranus, and we're going to round out with Neptune. So I have all 8 planets listed here. We want to go through and we're going to make bars to show our weight. I'm going to do just the first 2 on my paper, and then I'm going to have you guys finish up on your own. So Mercury is 37.8. That's just a little bit below 40. So I'm going to look at my 40. Yesterday we counted by 2s, so there wasn't a whole lot of options between, say, like 20 and 22. But when we're looking at 20 and 40, like that's a big gap. 37.8 is really close to 40, so we're going to go just a little bit below that 40. And then, again, I'm going to draw my line across, draw my lines down, do a quick squiggle. We're not going to waste time filling in these bars all neat and pretty. I like pretty, but this isn't the time for it. Next we have Venus. Venus is 90.7. So on Venus, 90.7, that's going to be kind of right halfway in between 80 and 100. So I'm going to go right in between, draw my line across, draw my 1, 2 lines down on the side, and squiggle that bad boy in. You're going to continue doing this for these 6 remaining bars. Now over here, we haven't gotten to this part with a graph yet, but it should be pretty self-explanatory. We're going to use our graph to help us answer these questions. So which planet does Maisie weigh the most on? If we're looking for which one she weighs the most on, we're going to look for the tallest bar. Which planet does Maisie weigh the least on? This time we're going to look for the shortest bar. How much more does Maisie weigh on Jupiter than Earth? When it's asking how much more, that means we're going to do some math. For this one, with math, it's going to be a lot easier to use your data table than your graph, because you're not going to necessarily be able to look at this bar and say, oh, that's 90.7. You want to make sure that you are using the data table to get specific numbers there. And then on which 2 planets is Maisie's weight the most similar? So if we're looking for similar, we're going to look for 2 planets, or 2 bars that are the same height. So this just kind of gives us a snapshot of how we can use graphs and data tables to figure out the information. I do want to talk to you real quick about the backside. So this one is on a chirping cricket, which I'm sure you all are very interested in. So a scientist does a controlled experiment to see if there is a correlation between the number of cricket chirps and the temperature. She controlled the temperature in a room and recorded the number of cricket chirps in 15 seconds. This time, the biggest difference from the back to the front, front to the back, is that we are going to be creating a line graph. So, when we create line graphs, which we haven't done as a class yet, setting it up, steps 1, 2, and 3 are going to be all pretty much the same. When we are talking about our independent variable, our x-axis, the number, it's going to be a little different because it's going to be numbers across. Whereas all the ones we've done so far, we've had categories across, or, categories across. But for this one, we're doing numbers across. If you look at the data table here, you'll see that the very first temperature is 60. Because we're going just from 60 to 80, doing a scale of 10s, even though it would fit across, it means that all of our data is going to be over on this side after our 6th bar, or our 6th grid. So what we're going to do instead is we're going to do something that I haven't taught you, but decided a video would be a great way to teach you, is we're going to draw this little lightning bolt symbol. And what that means is we're starting with 0, but we're going to skip ahead so that this line is 60. So we're drawing that little lightning bolt, and we're skipping ahead to 60. So now we have from this line to this line that we're going to get all the way to 80. So we're going to do, we're going to count it up. We have a gap of 20. So we have 20 degrees that we need represented, and we're going to try to figure out how many blocks we have. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So we have 11 blocks to represent 20 degrees. At this point, I would just do each block represents 2 degrees. So we're going to count by 2s, is what that means. So we're going to do 60, 62, 64, 66. What you'll notice as you're looking at my numbers here is that just like our y-axis, we need to make sure that the number corresponds with a line, not an empty block. Here, we had it match up with a block. But when we're using numbers, it always has to be on a line. So I'm going to continue numbering 68, 70, 72, 74, 76, 78, 80, 82. I don't have one that's at 82, so I'm just going to have that blank. You'll notice also, we don't have a 72, we don't have a 76 or a 78. That's totally fine. We're just going to plot the points that we do have. I'm going to set you up with the scale on your y-axis for this one as well, but then the rest of it, like as far as our title, our axes, you are going to be the one to label those. That's the part that's going to be most familiar to you because that's the one that we had our practice homework with yesterday. So for my y-axis, my largest number is that 44. I'm going to count how many blocks I have to get up to 44. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 44 divided by 12. We are going to, that's going to be just a little bit below 4. If I pull out my nifty calculator, I can do the actual math and it gives me 3.6 repeating. So like I said, a little bit below 4. We're going to count by 4s there. I know that 4s were not one of the ones that it mentioned on our notes from yesterday when we were doing, we talked about those naturally occurring or natural feeling intervals. If you would rather do 5, go for it. But I'm going to go ahead and do 4s real quick. So again, we always start at 0 there at the origin. 4, 8, 12, 16, 20, 24, 28, 32, 36, 40, 44, 48. So we've got our numbers here over on the x-axis for our independent variable. We've got our numbers here on the y-axis for our dependent variable. I'm going to show you again how to plot 2 points, just like I showed you 2 bars. You'll need to go back, write in your title, your labels, and then plot the rest of the points on your own and answer these last few questions. So, temperature at 60 degrees. I had 21 chirps in 15 seconds. So 60 degrees, I'm going to go up to 21. That's just a little bit above 20. This time, because we are doing a line graph and not bar graph, we are going to plot a point. At 62, I was up to 26. So 62 degrees, I'm going to go up to 26. This is just like when you are plotting a graph, plotting coordinate points in math. So I've got my 2 points. What I'm going to do next is I want to make sure that I connect these guys. So once you've plotted your points, you're going to draw a line to connect them. So you might have a zigzaggy line, that's totally okay, but you're going to plot all your points. Down below it says using the graph predict the number of chirps at 64 degrees and at 78 degrees. So when you are looking at your points, you're going to kind of see, so like let's say 61 degrees would be right around there. So I would guess that that was about 24 chirps. So you're going to figure out where your line is at that temperature. That's how you're going to solve those ones. Try your best. Focus especially on getting your bar graph done, and then move on to your line graph once you've finished. Best of luck. I will see you guys on Friday.